we recently announced our research program, which we call 6G Forward, and looking into 6 key aspects. First is new spectrum and topologies. Again, with every new technology or every new generation of cellular, there's always talk about new spectrum. And Sean has shown a slide there from Ericsson, which is a great slide. What I'm most, I would say, excited about is this thing called upper midband, really the spectrum between 7 and 24 gigahertz, sweet spot again of coverage and capacity, ripe for really more, much more massive MIMO to really be intelligent about using beamforming in those types of networks. But of course, sub-terahertz is important, and really using intelligent spectrum sharing. We've seen a lot of that over the years. A lot of researchers spend a lot of effort in this area, and hopefully we can see this in 6G. And again, new topologies, right? Really bringing in the satellite networks as part of the designing it in from the ground up for 6G would be great. Clearly for 5G, it was more of an add-on, and also cell-free massive MIMO, full duplex, mobile mesh. These are new topologies that we expect to see in 6G. AI and ML is the talk of the town right now, any technological circle. And really, we're talking about trying to infuse this machine learning and artificial intelligence across the entire network end to end. We talked a little bit about the physical layer. I would say that's, we start there, but to the MAC layer, to intelligent scheduling, to the whole network and optimizing entire network, and try to see how we can really fully utilize that, in a native manner throughout the network. The next thing is expanded verticals. You hear a lot about metaverse. You don't even, it's always in the news right now. What are these new applications that can really utilize a, low latency, precise location across an entire macro network, or in some cases, maybe localized indoor networks. The next one is optical wireless coalescence. And, in chemistry, coalescence means two things really coming together as one and no longer being separate. And, we've heard a lot of optical wireless convergence really for the past, I would say, 2 to 3 generations, and really utilizing fiber optic and wireless technologies to really form the network. Here, we're talking about truly merging these two worlds together. Concepts like all photonics networks, utilizing free space optical communication between satellites in these satellite networks, and further using fiber to see how we can utilize that to transport radio signals like radio over fiber. And again, you can't talk about the next generation without talking about security and resilience, right? It's important that we gain the public's trust in these public infrastructure, or even in the private infrastructure, increase security requirements there, utilizing zero trust principles. Post-quantum security is something, we're talking about timeframes of 2030 and beyond, right? There's a lot of talk right now on, quantum, obviously quantum computing, rendering a lot of our RSA security kind of, obsolete. And so, we need to start research on thinking about a post-quantum world in terms of security. And last but not the least, end-to-end cloud native, right? One can argue that 5G is already embracing the cloud, but to the extent of really, utilizing the distributed cloud all the way from the core to the edge, potentially even down to the devices, right? What does that mean from a truly distributed cloud? And again, utilizing the cloud infrastructure also for test and measurement, which is our bread and butter. And again, further disaggregating network principles like ORAN, and looking at that into the 6G realm.